I'm going to solve some growth problems, specifically with money. Throw money at the problem. Suppose you have $0 to invest. So this is any amount A0 in the beginning to invest in a savings account, earning an annual interest rate of R% compounded continuously. Furthermore, suppose that you make annual deposits of D dollars to the account. Differential equation governing the situation is as follows. Find an equation for the future value A of t of the account by solving the initial value problem. So aka solve the differential equation. So we have a linear differential equation and it's non-homogeneous, so we can use our integrating factor method. So we have dA dt minus r times a equals d, and then we have our mu equals e to the integral of negative r dt. We're integrating the coefficient of our dependent variable. So we get e to the negative rt. So that's our integrating factor. So we're going to multiply through. Left-hand side is the derivative of a of t times e to the negative rt. And we have our right-hand side d times e to the negative RT. So this D, of course, is a variable as opposed to the derivative operator, just to be clear about that. Moving this dt to the right-hand side, then we can integrate. Then we have left-hand side integral of that differential is just a times e to the negative RT. And then the right-hand side is d e to the negative RT divided by negative r, which is the derivative of the exponent, plus c. So now again, our goal is to solve for a of t. And then so we divide by e to the negative rt, which is akin to multiplying by e to the rt. So that neutralizes this guy. So we just have negative d over r. And then the plus c turns into c times e to the rt. So now we solve the initial value problem. So a at time 0 equals a0, which is our left-hand side. And so we can plug in 0 for t. So this is e to the r times 0, e to the 0, which is 1. So this becomes, once this goes to 1, we get c is equal to a0 plus d over r. So again, this does not really need to be there. C is equal to a0 plus d over r. So that gets substituted in there. And so our overall a of t is negative d over r plus c, which is now a0 plus d over r times e to the rt. So just to go ahead and check this, if you now again plug in 0 in for t, this should get us a0. So when we have 0 in for t, this e to the rt becomes 1. So we have 1 times all that. So we have a0 plus dr minus dr. And so the I said dr, but d over r, you got what I'm saying. The d over r's cancel. And so you're left with a0. Great, so that's part A. And then part B, they are asking for, upon graduating from college and starting career, you have no money. Great, thanks so much. However, during each year after that, you deposit $1,000, which is your D, your regular dollar amount that you deposit, and it pays 8% compounded continuously. Using your solution to part A, find the equation for the future value A of t of the account. So basically plugging in D equals 1,000 and R equals 0.08. And then what is the balance 40 years after you graduate? And how much interest is earned on the account after 40 years. So I went straight into solving a of 40, but if you wanted to first do a of t as it's asking you to do, you would do simply, again, plug in for d and r. So you have negative 1,000 over 0.08 plus, we're also plugging in 0 for a0, 1,000 over 0.08 e to the rt. So our new equation, if we can do 1,000 over 0.08 is 12,500. So this becomes, and if you see the d over r now can be factored out. So this 12,500 can be factored out. And then we have e to the rt minus 1. This 1,000 over 0.08 gives us 12,500. And we're factoring that out. And so what's left over is this negative 1 plus e to the rt. And so I'm just rearranging that to be e to the rt minus 1. So this is our new a of t. And then so we can go ahead and plug in, and also again, r is 0.08. Okay, so there you go. That's even better. We want our a of 40. So 12,500 e to the 0.08 times 40, 3.2 minus 1. So e to the 3.2 is 24 point something minus 1 times 12,500. This is our 294,156. And to the nearest cent, it's 63 cents. So that's our account balance. And then how much interest is the account balance minus the amount invested. So the amount invested is $1,000 per year times 40 years, $40,000. So we're subtracting $40,000 from our $294,000. And you can see that for 10B, it is indeed confirmed that the cash value of the account is $294,156.63. And yeah, subtract $40,000 for the amount of interest. So again, most of it is interest if you invest consistently over time, which is the whole point of investing. Okay, find the value of an annual deposit D that would produce a balance of $1 million 40 years later. What they didn't say explicitly, but it's implied that with the same interest rate. So same interest rate R of 8% or 0.08. Set A of T equal to, or rather A of 40 equal to $1 million. We're solving for D over 0.08 equals e to the 3.2 minus 1. And so you can multiply your $1 million times 0.08, $80,000, divided by e to the 3.2 minus 1, which is again 23.533. It should get you something exactly like this. You plug it into your calculator. So $1 million after 40 years if you invest $3,399.55 per year, of course, assuming that it's compounded continuously. Okay, and part D. If the annual deposit is $2,500, what should be the value of the interest R in order for the account balance to be $1 million after 40 years? What if you didn't want to deposit $3,399? What if you just could afford $2,500 per year? What would the interest rate need to be in order to get the account balance to $1 million? So now again, we have our D given of 2,500 and R is our unknown. The $1 million is the same. So again, we have this $2,500 over R can get factored out. And then when we move it to the other side, it becomes 1 million times R divided by 2,500. So the 400 comes from 1 million divided by 2,500. That's 400 R equals -1 plus e to the 40 R. From this, what I did was, because it says to use some kind of either graphing calculator or numerical solver. So I just plugged this equation in on Desmos and look for the roots. One of the roots is 0. So if you plug in 0, you can find that out here. E to the 0 is 1. 400 times 0 is 0. So 1 minus 1 is 0. So that's one root. Doesn't help us. The other root is this 0.0904. And it says to round the interest rate to the nearest 1/100th of a percent. So if you have a 9% interest rate, and this goes to show the effect of just what 1 percentage point of interest can make of a difference. So we had previously 8% and you needed $3,399.55 per year compounded continuously to get to $1 million after 40 years. But if you add 1 percentage point, you only need to deposit about 2/3 of this in order to reach your same $1 million goal. So finally, number 11, you're having surgery. You must be anesthetized. Say that 10 times fast. The anesthesiologist knows that you'll be under when the concentration of anesthetic in your blood is at least 50 milligrams per kilogram of body weight. Okay, so that's the required concentration. Okay. Suppose that your weight is 100 kilograms. The anesthetic is eliminated from the bloodstream at a rate proportional to the amount present. If the half-life of the anesthetic is 10 hours, what single dose should you be given to stay anesthetized for 3 hours? Round your answer to the nearest 100th of a gram. Pay attention to units. So we got grams, milligrams, kilograms, all mixing together here. We need a certain concentration in order to be anesthetized, but you don't administer a concentration, you administer an amount. So we want the amount in grams of the anesthetic. So the first thing to do is to convert this concentration to a total amount. So we have 50 milligrams per kilogram, but we have 100 kilogram person. So 100 kilograms turns into 5,000 milligrams. And then our further conversion factor would be, 1,000 milligrams per gram. So this is equal to 5 grams of anesthetic is needed after 3 hours because we need to be under for 3 hours. Stay anesthetized for 3 hours. So the other point that they make here regarding the differential equation is that the rate of clearing of the anesthetic is proportional to the amount present. So translating that into real language, aka math, our differential equation is going to read, and I'm using A for the amount of the total amount of anesthetic present at time t. It says it's eliminated proportional to the amount present. Again, and eliminated indicates our negative sign. Proportional, this is our constant of proportionality. So the rate of clearing, the amount that is leaving at any given time is proportional to the amount present. So not concentration, remember it's amount. Already, this is a separable differential equation by simply moving the a to the other side, dt to the other side. So dA over a equals negative k dt. Integrate both sides, ln of a equals negative kt plus c. A of t equals c times e to the negative kt by exponentiating both sides. Our initial condition, plug in 0. That is, they don't tell us what this is, but we're going to call it A0. And so that A0 is going to be what our C is. All right, and that's ultimately what we're solving for. They give us the additional piece of information that the half-life is 10 hours, which means at time 10, half of the original amount is present. We use that information to say, okay, 1/2 A0 is equal to A0 e to the negative kt. We don't know k yet, so that's the purpose of this. And that happens at t equals 10 hours. So the A0s cancel. Now we can take the ln of both sides. So the ln of e, that cancels. So we get negative 10k. The reason I make this negative ln 2 is just because I know how these problems are supposed to work. But technically it is ln of 1/2. So ln of 1/2 is equal to the negative ln of 2. That's equal to negative 10k. And then so we can positive, k equals ln of 2 over 10. We plug that in for k. So now our a of t reads A0 times e to the negative ln of 2 times t all over 10. The e to the ln, we talked about this, is those operations functionally cancel each other, all right, e to the ln. So, and then this negative ln of 2, again, if we switch the negative back to make it basically ln of 1/2, so e to the ln of 1/2 becomes 1/2. So it's 1/2 to the power of t over 10. A of 3, the amount at time t equals 3 hours needs to be 5 grams. That was from our earlier calculation that we discussed. So 5 grams equals A0 times 1/2 to the power of 3 over 10, which is just 0.3 by plugging in, again, t equals 3. When you do this process here, 5 over that, approximately 6.16 grams as our initial amount, and that is confirmed in your answer. All right, go get them.